Thank you for tuning in to this webinar on overall equipment effectiveness. My name is Matt Giordano. I'm a technical evangelist here at Rockwell Automation, and I'll be going through a discussion today about OEE and what it means to your business. So what are your priorities right now? Are you trying to do things like reduce downtime or reduce unit costs, reduce cycle time variation, or increase production without buying new equipment, or improving quality? Essentially, all of these things really come down to it's reducing costs, right? And different ways that you can find to reduce the cost of your operation. And to do that, you might be looking at things like an OEE analysis system, downtime tracking or machine monitoring, a lean or process improvement project. So what is OEE? OEE is a numerical value assigned to the improvement opportunity for a given piece of equipment. It factors in the availability, performance, and quality of output of a given piece of equipment, and it tells you how much right first-time product did this machine produce compared to what it could have produced in an allocated time frame, such as a shift or a day. And it tells you, is this piece of equipment effective within the value stream? Is it allowing you to meet your present or future customer demand? And if you're not able to meet that demand, then OEE can help you analyze the reasons why so that you can then go and address them. So OEE calculation takes into account the 6 big losses and puts them into a single number that represents the effective operating rate for a piece of equipment or a line, for example. And basically this translates to the percentage of product produced compared to what could have produced in a given time frame. So let's just take a shift, for example. How much did we produce versus how much we could have produced if we'd had an ideal situation of no downtime, no speed loss, and no quality loss. So there's basically 3 categories that these 6 big losses fall into, right? And those equate to the 3 factors of OEE. So starting with availability or downtime, within the availability category, you have things like equipment failures or unexpected downtime, breakdowns, and then you also have setup and adjustment time. So if I'm doing a changeover to a different size product or different flavor, etc., as we make changes to what we're producing, that's downtime that we're not producing. So that calculates against our availability. The second category is performance, right? So this is how we are producing in terms of our actual speed or throughput versus our ideal. Right? So do we have times where equipment is idling, or are we running at a reduced speed from what our ideal rates should be? And then the third factor or category is quality. And so are we producing scrap product or product that needs to be repaired, or are we having reduced yield from the time we start the equipment up until we get to stable production? So why does OEE make sense as a measure in a system for evaluating what is going on in our operations? There are 3 general ways to reduce the cost of an automated process, and they are to reduce unproductive machine time, reduce the cycle times, and reduce the waste or scrap production. Right? And OEE measures the 3 things that reduce costs. Right? The productive time is availability, the cycle times equates to the performance measure, and the waste or scrap equates to the quality measure. And so when you take these 3 factors together, you come up with the overall equipment effectiveness measure, or OEE. A higher OEE really equates to lower costs. So I'm going to kind of step through each one of the OEE factors here and go through them in detail. All right, so we're going to talk about availability, and availability is the ratio of the actual running time to the expected running time. As we see here in the formula, it's running time divided by available time. So available time is considered to be the time that the equipment is expected to be producing, right? So for example, it could be a shift, right? Within that shift, the available time does not typically include time that you've set aside for things like planned maintenance, breaks, etc. Available time can be further reduced if a machine is not needed to meet production. So these are factors that will define the total time that we expect to be running, and then we look at the actual time that we did run, right? So running time is actual production time that does not include downtime, setup, adjustment, breakdowns, etc. Right, so this is the first factor of the OEE equation. The second factor relates to speed or performance. And we look at our actual output divided by our standard output. And the rule of thumb here is to use the best output rate known on this machine, and that's whether this is above or below the design speed. Right? Because when you're defining what the standard output should be, if a machine typically outperforms its best output rate, then you're going to have performance measures that are greater than 100%, which really should not be happening. On the other hand, if your machine has never been able to achieve its design speed, then it's probably not helpful to use that as your standard measure, right? So we want to pick a value here that represents an achievable standard output and a desired standard output, right? And then we're going to compare our actual output against that to see how well we're doing from a performance measure. Right, and so any losses due to running at less than ideal rates are going to show up in the performance percentage portion of the OEE calculation. The third factor is quality, and here we're looking at the amount of right first time output versus our total output. And so what we want to do is see how much of our good production compared to our total production, right? So if we've got anything that is defective in terms it needs reworked or repaired, or it's scrapped, or for whatever reason it does not count as good output or product, then this is where we're going to see this hit the OEE calculation. Okay, we're going to take a look at OEE for a given time frame, for example, and look at the breakdown of the different factors of OEE and what goes into that calculation. So we're going to start out with one shift, and we're going to look at each of the components here as we go. Right, so starting with available time, we have our shift time, and then we've taken out of there some scheduled unavailable times, things like breaks, scheduled maintenance. That'll determine what our total available time for the shift is going to be. And then as we start diving into the OEE factors, we look at our availability percentage. And so we've got our running time divided by our available time. So here we see we have some segment of downtime or non-productive time that we weren't running when we should have been. Right? So again, these could be breakdowns, setups, changeovers, etc. But it's some chunk of time where we're not running and we should have been. And then we step down to performance, and we look at our production at rated speed, and we have some element of speed loss in there. So we weren't running at optimum speed for whatever reason, or we have variation in our speed. We're not running consistently. These are factors that can hit the performance percentage. And then we look at our quality percentage, right? We've got our good production versus a measure of scrap production that's in there. And so if we take all three of those buckets together, we get down to the bottom here. We see here's our OEE percentage, and then here is our loss capacity, right? And that loss capacity is, the availability, performance, and quality losses, or areas that we can go and improve. So why is OEE such a prevalent measure? It's a simple performance indicator that everybody can relate to. It's the ratio of good parts produced versus what you could have produced if you'd had no downtime, no loss in speed, and no scrap, right? So it really boils down to here's how we did versus how we could have done, right? Actual versus ideal. You can apply it to any machine in any industry, anywhere in the world. It shows a machine's actual performance compared to its theoretical maximum. It can be used to compare performance of machines, lines, operators by product, etc. Right? So there's lots of different ways that you can measure an equipment's performance by this value. Looking at this from a little bit different way, if you are running normally, you're meeting your schedules, you may think there's nothing to improve. Metrics like a build to schedule metric don't really tell you whether machines or your lines are being used effectively. Your target in this case is based on the schedule or your present demand, but not the theoretical capacity of that machine or line. You might be running at a reduced speed, but you're still reaching the targets that you have. But when you have a team that focuses on OEE on each step in a line or each machine, generally they can identify opportunities in reducing the 6 big losses that we talked about earlier. OEE helps match the theoretical capacity of your equipment with your production demands. So kind of looking at this in a couple different ways. If you're not meeting demand and you find that your equipment is underperforming, you got a low OEE, then you have an equipment effectiveness problem that you can go and address and improve that OEE. If you're running at a high OEE value, but you're still not meeting the demands that you have, then you have a capacity problem, right? And even if you are meeting your demand without OEE, you're not really able to tell if you have spare capacity in your current setup to keep up with whatever changes in demand that may come your way. OEE is commonly used to provide evidence required to justify capacity expansion investments. OEE packs a lot of information into one number. Sometimes that can make it difficult to calculate or confusing to interpret. People usually get into trouble when they try to use OEE as anything other than a high-level KPI. Assuming that OEE on every piece of equipment is equally important, or they gauge themselves against some world-class OEE measure, and focusing on the number, just kind of purely on the number, instead of the improvement value or context that it provides. Sometimes it can be used as a club rather than a yardstick, and that assuming that OEE will just improve because now it's visible. The real value of OEE is that it helps you understand where your losses are happening and analyze where they're happening so you can identify what areas to focus on for improvement, right? And then it allows you to circle back and measure the improvement efforts that you've made to see if they're effective. The OEE number itself can't tell you all that you need to know. It doesn't tell you where or why you're experiencing losses, right? You might be operating at 89% of perfect, but you have to look beyond that, right, to analyze your losses, right? It can be used to teach people what loss is and how to look for it, right? So knowing these OEE and the factors of OEE is not enough to move the needle, right? You need to not only look at these high-level factors, but you also need to start diving into the next layer down, right? So when we think about, it's not just availability, but you need to look at the detailed, machine-specific tracking of things like downtime events, changeover events. What are the reasons they are happening? It's not just performance, but you need to track cycle times and look at those cycle times by product, by shift, by operator. And it's not just quality. It's okay, we have scrap. Why do we have scrap? Can we assign reasons or categories to the scrap production so that we can start to identify, where we can focus our efforts on reducing that scrap production? So there's a lot of other information that is out there that you would want to look at to help drive the OEE needle and make improvements. A lot of times we see information still gathered manually, right? So typically, people are jotting stuff down on paper, putting it into an Excel spreadsheet, right? So, doing manual collection of information, gathering data is tedious, it's time consuming, it's expensive in terms of overhead costs. If you got people that have to walk around and take down this data, oftentimes it's inaccurate or incomplete. By the time somebody can look at that information and start to analyze it and try to take some action on it, the data is stale, right? It's old. It's a day or a few days old, a week old. You don't have data and reports that you can, take a look at and dive into to do some analysis. And oftentimes the data is not detailed enough for you to really take action on, right? And a lot of times you don't have time to do it because you still have to meet current production goals, right? As well. That's your primary focus. So how can you improve efficiency, right? The key really is collecting and getting at data, right? Not in a clipboard, not on an Excel sheet. You've got a control system sitting there that chances are has most, if not all, the data you're going to need to calculate OEE, right? What kind of data are we looking for? We're looking for part counters. We're looking for scrap counters. We're looking for, cycle times. Looking for downtime events. When the machine has dropped out of a run state, now they're in a down state, or when it's in an unproductive mode. When it's blocked or starved, right? When it's producing scrap production, right? Chances are that information is already in the control system. It just needs to be tapped into. And so what is the value here? If I can automate the data collection, right? I'm getting data from the control system. It's timely, it's reliable, it's coming straight from the process. So it's accurate, it's precise, right? And it allows us to then analyze individual operations of the line itself or the components that make up that line, right? So you can look at things like OEE and downtime and events that can be measured across the line or at each component of the line. And what do you do with the information once you've collected it? Well, the first step is looking at how you're doing right now, right? What's our OEE? What are the three factors of OEE? Are we having a downtime issue? Are we having a speed loss issue? Are we having a quality issue, right? So how are we doing? What's happening right now? Where are our real problems? So say, for example, we have a downtime issue. Okay, so we should maybe focus on that first so that we can try to make an improvement there, getting our uptime higher. Right, so we take an area to focus on, take some action upon that, and then with the data continuing to be collected, that allows us to measure the improvements that we've made or we think that we've made and to see what the impact is. Okay, did that really help? Right, and basically we just repeat this process, right? We come back around, we look at how we're doing, what's going on right now. Did our previous changes or improvements have an effect? Can we improve that factor further, or is there another part of the OEE situation that we want to focus in on for another round of improvements, right? And this can just be a continuous cycle that you go through to improve operations. So what kind of payoffs can you see? Right. So as I mentioned at the very beginning, this is all about reducing costs, right? So decreasing the manufacturing costs, things like less overtime, reduced labor costs, lower per unit costs, decreased overhead costs. So if you have automated data collection, you're saving time and money in collecting data, preparing reports. You can defer capital expenditures, so get more out of the equipment that you have, right? And increase the capacity, right? So if you can get more product revenue and profit in the same amount of time, you're doing well, right? If you think about what kind of impact that could have, if you have a 1% increase in efficiency in a 50 million a year plant running at 50% OEE, that's $1 million per year in increased production. So even a percentage point can have a major impact. Some conclusions here. Automated performance monitoring can enhance your business results and reduce costs. So some things to take away from this is OEE by itself isn't enough. You also need some of that additional data that we talked about, right? So downtime reasons, scrap reasons, tracking the cycle times, right? So that you can start to drive into the underlying causes or factors that drive that OEE value, right? You probably already have the data in the control systems, and you can benefit from a system that utilizes that existing control system to get that accurate and timely data, get the OEE calculations and the details you need to improve it, track other events that might have nothing to do with downtime. Maybe they're scrap events, maybe they're cycle time events, etc. But present that information to you and those who need it so that you can start to make improvements and measure those improvements and thus increase your profitability. Thank you very much for attending this webinar. If you have further questions, please feel free to contact us at our website, rockwellautomation.com.